Right, okay, over to James. I think we've heard James talk a bit on 3D printing before. And if we play our cards right, not only will we get him on 3D printing, we'll get him on some other things as well if we play our cards right. So over to you, James, thank you.
Okay, is the transmitter on working? Good. Hi everyone, so obviously I've not brought a 3D printer in, so I'm going to try and show you as much as we can without actually printing. The printing bit is probably the easiest of the whole thing, so I'm going to show you what's involved in actually up until the point when you hit print and stuff happens. And I'm going to tell you about some of the things that have happened along the way and some of the things I've printed. We've already had a talk at the club talking about the history of it and the benefits, so I'm not going to go over any of that, but some of the things that we'll talk about today are very briefly just the types of printers and which one I'm going to specifically talk about, some of the materials that you can print in, what actually makes up a 3D printer, what the parts, and then all of the steps that are involved in printing. So the CAD, the slicing, the preparation of your printer, the actual printing, any maintenance that you might want to do, and some other stuff towards the end. So just a few moments just to talk about printer types. So we're probably all familiar with this type, which is an FDM printer. So this is pretty much what we're going to be talking about for the rest of the evening. Stands for fused deposition modeling, and essentially we're taking a plastic filament, which I have a piece of filament for anyone who hasn't seen them, which we can pass around, a few different colours there, just so you get the idea. And essentially it just melts the plastic filament in something called a hot end and pushes it out onto a plate. But we'll talk about that a little bit later. This is see the website because there was a previous talk that spoke about all that. I think there's been 3D printing. There was certainly some patents that were talked about back in the 1980s for this type of printing here, which is SLA printing. If it was done with FDM prior to that, I'm not sure. I think we were probably told, but I can't remember all the details. So this is SLA printing. This costs a lot more to get into than FDM printing, and essentially it's a laser beam at near UV frequencies, and it's squirting itself at some horrible goo, which essentially solidifies, and the build plate lifts up, and you end up with a 3D print. The quality of the prints that you get from an SLA printer is typically far better than you would get from an FDM printer, but you've got to mess around with that horrible. What would you use something like that for? Same kind of thing, but it would be used professionally rather than a professional printing company having it on. Many FDM printers, you would see this kind of technology in big machines, and they would print it that way. So you can get far better quality out of an SLA printer. No, you could use it for all kinds of things.
That looks like making a vase.
It does, doesn't it? My dad's company used to send 3D prints out for hydraulic pumps, and they, rather than doing all the machining for all of those, they would 3D print them and then do create the machines or the tooling once at the end, once they proved it worked. So that's SLA. You don't really want any of that horrible goop anywhere because it's not very pleasant. And this is becoming a little bit more popular. This is carbon clip technology. Works fairly similarly to the one that you've seen. You've still got that horrible goop, but there are two possibilities in there. You can have a DLP projector sat underneath there, projecting light up into it, or alternatively, I've seen very small ones which are a little bit cheaper, where they use screens like on your mobile phone, and actually there'll be effectively a mobile phone in there, and you're exposing that horrible goop. The downside of this type of technology is you are printing 100% infill. Now I'll explain what that means in a minute, but essentially you're always creating solid objects when you're printing. If you are, and also the time involved is dependent on the size of the object, not how much material is being exposed. So it doesn't matter whether you were printing something very small and very tall, the amount of time to actually print that would be identical to printing something very wide but also very tall. It would be exactly the same amount of time. It's becoming more popular now, but again, it's extremely messy, and you don't really want to be messing around with all of that goop. But it is now getting cheap enough. I think you can. The cheapest one I've seen is about £500 so far, and you can get one at home. So this is probably the most common industrial type, and this would be something the size of a American fridge freezer, I would imagine. This is selective laser sintering. Essentially what you have here is a box of powder, and a laser is sintering the powder one layer at a time, and then the machine comes over and swipes over again, and the platform has moved down, and then it sinters the next layer. And then at the end, when the whole print is finished, you sort of lift it out of the vat of powder, brush it all off, and it's done, it's all finished. But again, you need pretty large machines for that. It's not really something you can do at home. You can't really read that, but this is just showing you the benefits of each of those techniques and the kind of layer thicknesses that you can get. So in terms of FDM, the benefits are it's extremely cheap and easy to get into, quite clean, but it's not the quality that you can achieve is not quite so good as the other technologies. Which one are we looking at here? Minimum 1 mil for FDM, and then what was that 0.8 for SLS, 5 millimeters for SLA, and 0.5 millimeters for the clip type. So that just gives you an overview of the various printing technologies open to you, but probably FDM is the one that most people would have at their house nowadays. So we're going to stick with FDM from this point going forward. So the types of materials you can print, this is not all of them, this is just some examples, and you need to be a chemist really to understand what all of these happen to be, but we'll just call them by their abbreviations. So PLA is the material that's easiest to print, and I think all of those pieces that we're sending around are all PLA filaments. The benefit of that is it's extremely easy to print. You don't have to do anything particularly complicated. You don't have to have a heated bed. You don't have to really worry too much about the temperatures that you're printing at. It's probably the best starter material to print out of. The downside of it, and that's one of the things I'm going to show you in a minute, is it does fall to pieces pretty quickly when you start heating it up. So I've got some hot water here, and I'm just going to give you a little demonstration of what can happen. So we have just a scrap piece of material that I've printed in PLA. It's quite solid. Drop it in the water for a minute, and we'll come back to that. So the next most common is ABS. We've all heard of ABS. That's its technical name. It's a little bit harder to print. You do need a heated bed for printing ABS, and typically you want a heated chamber as well. So the easiest way of getting a heated chamber is just to put a cardboard box over the printer. You can buy special enclosures made of various materials, but if you can get a cardboard box that's big enough, set your printer going and just put the cardboard box over it. That's by far the easiest way of doing it. ASA is another material that you will probably have heard of before. That is one that is it's derived from, let's get this right, derived from ABS, so it prints in the same kind of way, but it's less susceptible to UV. So ABS can break down with some UV. PETG is a kind of mix between the PLA and an ABS, in terms of it's as easy to print as PLA, but it's as hard wearing as ABS. So again, these are just some of the examples of materials. Nylon's available. The downside with nylon is you need to keep it dry before you print. If you don't keep it dry, it will it will soak up water, and it will become a nightmare, become useless. You need to throw it away. So you can already see that that's now
Wow.
bendable, and
Will
it's.
it harden again when it goes down?
It will harden again. So
That
that's
could
actually
be a tool
it
for
could be
being able to-
it could be a benefit.
Mould it down.
It could be a benefit. I've got some little beads which are fantastic for moulding. They're little plastic beads, and you drop them in some hot water. And I'm thinking probably those beads are probably PLA based or something like that, because you mould them, they harden, and they stay as they were. So I've repaired quite a few things with these little plastic beads. So as I said, nylon's quite strong. I've seen people make propellers and things impellers for boats and things like that out of nylon. The downside is you need to keep it. The ironic thing is you need to keep it dry before you print, but once it's actually printed, then it's absolutely fine after that. And then you can get flexible materials, which are a nightmare to print if you haven't got the right kind of printer available, but that will print something that's a bit like rubber, which is something I want to try in the future. I haven't done yet, but there are tons of flexible filaments available. Because this technology is starting to explode now, there are many, many, many companies who are producing their own filaments. And some people are creating hybrids of the materials that you can see above and various other materials. So that's, I guess, where some of these PETG type materials came from before, is they're getting one of the benefits of it's easy to print, but it's hard wearing, things like that. Well, that's what the infused ones are. So infused ones are basically a plastic filament, and they infuse them with wood or steel or brass or bronze or you name it. You can get things that have got these materials in them. And when you print, they will then, they're not 100% wood, but they will look like wood at the end, or they will start to rust, for example. If you want that effect of something looking rusty, you can get that. It also adds weight to it, which is also nice if you want to print something, but it needs to have some physical weight to it, because these things weigh almost nothing once they're printed, even if you print solidly. And there seems to be a trend at the moment now for also infusing some of these filaments with smells.
Oh my
So
God.
the funniest filament I've seen recently is coffee infused. It doesn't smell in its roll of filament, but it smells whilst you're printing, and then there is no smell once you've printed. So I don't know quite what the reason for that is, but it's
Some people do that cookie, I think.
I was going to say, if you put it near any heat, would the smell come?
I don't know. Yes, I would imagine so, but I don't know how hot you would need to get it before before you start to release the coffee infusion. But
I wouldn't say so.
Is it conductive when it's printed with metal?
yes, they do become conductive depending on the type of material.
So how do the heads cope with you changing from one product to another?
How do they cope? If you are printing an infused material, then you will expect to change parts on your printer regularly, because they will start to wear away the nozzle and things like that.
Similar to a normal laser printer, or is it similar to?
No, I'll show you some of those bits in a little while, but it's relatively straightforward to change the filament. Sometimes it's a pain in the backside, and that's why you'll find things that I've printed in fun colours, just because I didn't want to go to the effort of changing the filament. Sometimes it will take 2 minutes, sometimes it will take 15. So if I want to print something quickly, sod's law, it'll be 15 minutes, because it won't have gone so well. So the whole point of the talk, and where we're trying to get to, is 3D printing is wonderful for people who like to build things or play with things. Is it consumer ready? Probably not at this point. There are still things you need to do to actually make this whole thing work. It's not just like your laser printer where you hit print and something comes out perfectly every time. There is still an element of it needs to be set up. You need to dial it in, configure it, those kind of things. But to be honest, the only issues that I've had since setting all that up is changing filament. So it doesn't have to be all that bad. Yes, you do it with a computer, but again, I'll show you. It doesn't have to be as complex as you imagine. So this is what a typical FDM 3D printer will look like. There's 3 axes: the X, Y, and Z axis. The Z axis you can see is going up and down. The X and Y axes are either moving the plate or moving the gantry there, which in this case would hold the extruder. So this is the printer that I have. It was extremely cheap. If you are in the market for a 3D printer, probably today and tomorrow are one of your best times to be buying a 3D printer. Yeah, Black Friday. I bought mine on sale a few months ago, and I paid £130, I think, for this as a kit. It came from China, and I have to assemble it. It's easy to assemble. It's not difficult at all. This is the ANET A6, which is the newer version from the ANET A8. It's pretty much the same as the ANET A8, although can I get a mouse working here? Although this screen at the top here is an LCD, sorry, a graphic LCD screen, as opposed to the ANET A8 has a 4x20 LCD screen. But other than that, it's pretty much identical.
So in real life, how big is that?
It's, what we're looking at, it probably sits about that high on the table by that. So it's relatively small. It's got a build area of about, this plate here is capable of creating a print in millimeters, 220 by 220 by 220. So it's a reasonable size plate. So let's try and point out some of the areas. So when we're talking about these, you kind of know what we're talking about. So down here, this is the hot end. You can't really see a great deal of from that particular photo. We'll zoom in a little bit later, but that's essentially what a hot end will look like. In fact, that's not even strictly true if we're talking about just the hot end. That is the hot end. It's essentially just a block of aluminium with a heating element inside here and a nozzle on the end. So you can see the little nozzle just in here. And then what sits above this heating element is something called the heat break, which, if I take this off, that's a heat break. Essentially, it's just a metal tube with some kind of heat sink on it. And the idea of that is, if you've got a unit like this, which is heating up filament, over time, it will conduct heat to anything that's just touching to it. And what you don't want to do is just heat all the way up and start melting your filament up here when you want it to be hot down here. So what this is actually doing is cooling the filament, or keeping it cool above the hot end. So what we have, this isn't the one that I've got in my printer, but it might well be at some point in the future. What you then have is some active cooling here with a fan, which sits in front of the heat sink, which I have on mine. And there's the example of the little fan that came with this. Now what we're finding at the moment is this here is a Chinese clone of something called an E3D hot end. So E3D are a UK company. They seem to be pioneering these hot ends, and as soon as they release one, within a few days, China has cloned it and they're selling it for a fraction of the price. Fundamentally, they are almost identical. The quality is questionable about whether they are quite so good. So you may be lucky, you may not. The hot ends from E3D aren't that expensive, but actually, I think this whole outfit here was about £4, so from China, whereas it might have cost £20 or £30 for the real one. Everything in China is super cheap, but you do get what you pay for. So if you buy something cheap, you've got to expect to give it a little bit of love and maybe do some repairs. So then we have these things called linear rails, and they are basically these rails here that are not threaded, and they just allow the gantries to move. We have the fans. On this there are two fans. We've got the one calling the heat break, and then we've got another kind of snail fan on the side here with a little 3D printed funnel, vent, whatever you call it, and that's the part that blows hot, cool air onto the part itself. So it's the part cooler. So this element here is what you would call the bed, and that is typically an aluminium plate. And if you've bought a good printer, and again mine was only 120 quid, 130 quid, but you can buy printers without a heated bed. So what this is an aluminium plate with a heating element built into it that allows you to warm the aluminium plate, and therefore, rather than printing onto a cold piece of aluminium, you're warming that up, and therefore, hopefully, printing onto something which is not just going to pop immediately off of the aluminium plate. We've moved on quite a bit from when these whole things started, so I'm sure some of you who've looked into 3D printing before will have heard all kinds of interesting stories about blue painter's tape and hairspray and all kinds of things like that. They were all tricks that were used for keeping the item to the bed. So the last thing you want to do is to print something and find it moves, which is exactly what happened the first time I printed something. I had no idea what I was doing, so I hit print, and that's what happened. It printed absolutely fine to start with, and then I went and made a cup of tea, and I came back, and then there was this little spider's mess on the other end. So give you an example, and I cancelled it, and that was the end. So the important thing is you must keep the part adhered to the bed. So the reason people were using hairspray, and I think Aquanet was the American brand that everybody was raving about. Ultimately, Aquanet contains a material which I'm sure you're all very aware of, called PVA. Does everyone know what PVA is? So it sticks extremely well. But you'll also find that people are using the PVA glue sticks, or they're mixing the school PVA up. I've done that as well, and you just paint it onto the surface and away you go. That is one way of sticking your prints to the bed. The downside is it's a little bit messy, but that's how it was done up until fairly recently. There are alternatives, and we'll come to those in a minute. Then we have stepper motors, and this one we have a few stepper motors. We have two at the bottom for allowing the Z-axis to move up and down. We've got one here which is basically controlling the movement in this direction. We have another stepper motor behind this fan here, which is basically moving the filament and forcing the filament through the hot end. We have another one hiding behind the bed here, which is allowing the bed to move backwards and forwards. So then we have lead screws, which are these little threaded bars here, and they basically stop gravity affecting these and just forcing them down. So they basically wind the unit up. It's very important in this type of printer where you have effectively two stepper motors on each side, or one on each side, to ensure that these are perfectly level. So Jonathan, I know, has just bought one of these. So the important thing for you, Jonathan, when you set this up, is to stick a ruler on the table, running up here, and then manually wind these until they are exactly the same level. A number of times I've accidentally knocked this and then tried leveling the bed, and then found it was completely out and thought, oh, something's gone terribly wrong, and started manually adjusting the bed, and then realised that I'd obviously knocked this and needed to reset them. So this is the kind of maintenance and manual messing around that I'm talking about you need to be aware of. If you buy some of the other units, they're in a big box, you haven't got any of that access to any of these things. They will self-calibrate, but you're going to be paying a lot more than £130 for a unit like that for comparable quality, actually. So then we have belts. These are running across here, which is basically pulling and pushing this extruder left and right, and also moving the bed forward and backwards. The extruder is basically I think I have a picture of that in a second, so we'll show you that. But that's basically the bit that pushes the filament into the hot end. We have some bearings which need oiling regularly, and then we've got the nozzle, which we spoke about. So that's, for anyone who couldn't see that hot end, that's what a hot end will look like. You can see here we have a nozzle, we have the aluminium block, we have the what's this called, heating element in here, and a thermistor here, so the unit can actually work out what temperature it is. Then we have a nozzle. Nozzles are interchangeable. I bought a whole bag of them all for 50p or something from China. They come with different size little holes at the top. So the typical printing size would be 0.4 millimeters. I've made my standard 0.2, but you can get 0.1, and obviously the smaller the hole, the finer the quality, the longer the print time. So I think that's why most people stick with 0.4, because they get the benefit of reasonable quality for reasonable print time. I'm not so bothered, I can wait or run it overnight, so I kind of stick in the middle with my 0.2 millimeters. So there's an example of another heat break that we showed you, slightly different design, but that's what they look like. This is this is what it used to be like when people made things out of wood, but this is effectively how the inside of the extruder looks like. You can see behind here we have a stepper motor, and that essentially is turning this geared wheel, which is biting into the extruder, biting into the filament and then pushing it downwards. And then you've got another wheel here, which is essentially keeping the filament pushed against these geared teeth. And then what you'll typically find is a system like this. On mine it was a big screw sticking up, and what you can do is push that down, and that releases this little wheel here, which allows you to move the filament freely should you want to be able to pull it back out again, or even push it down maybe to clear a block. So you can see there's not really much engineering involved in probably one of the most complicated bits in the system. But this is the bit that will jam sometimes or skip or things like that. So it's probably one of the most useful bits to know something about. So how do you actually print something? Well, you need to start by having a model, and that would typically start with CAD, which stands for computer-aided design. There are tons and tons of 3D design programs out there. I'm going to show you Fusion 360 tonight, which is from Autodesk. I'm sure most of you will have probably heard of AutoCAD over the years. So Autodesk seem to be buying everybody up now, so they even own the Eagle PCB software that I presented before, so they've bought that now as well, and are marching that forward. And then there are other free bits of software as well that are based online. So Tinkercad is one. It's very, very basic. It's totally free, but if you just want to move boxes and cylinders and things like that around on the screen to create something, then it's absolutely fine. But if you want to do anything serious, I would spend the time investing in Fusion 360, because you're going to quickly outgrow Tinkercad unless you're doing just plain boxes, I would imagine. Then there's Onshape, which is another free website, which is pretty comparable to Fusion 360 actually. The only downside of it is it's only free to use if you make all of your designs open to the public at all times. If you haven't got a problem with that, then Onshape is a great possibility for you to have a look at. But it might be that you've got no CAD skills and you don't you don't have any intention, you just want to get somebody to do the work for you, in which case there's a website called Thingiverse, which we'll have a look at a little bit later on. And that is a website where you can type something in, and people like me who have designed things upload it for free for other people, and they can just hit download, send to printer, done. So it can be as simple as that. And ultimately, the thing that you're looking to get at the end of this is an STL file, which is typically a binary file that contains the 3D model that you're then going to slice. So all of those pieces of software that we spoke about at the top will produce STL files, and Thingiverse will allow you to download STL files. So we'll go through that in a bit. Once you've created your CAD model, then you need to do something called slicing. And slicing is where you are basically creating the code that tells your 3D printer what you're going to print. So anybody who has done anything with a CNC machine will know that you can take a 2D design or a 3D design, and you basically you turn it into something called G-code, which is basically just some commands that say move the Z-axis 2 stops, move the X-axis so much, push the filament down this much. It's just a series of commands. But they are typically industry standard commands that people are sticking with, that your 3D printer of any manufacturer will understand. That's the language that they speak. So there's loads of software out there for slicing your 3D models. I'll start with Simplify 3D, which is the software which I bought. Probably cost me as much as the printer for a piece of software. The reason being is at the moment it seems to be the most not only user-friendly piece of software, but technically it's got more features than some of the others. Then there are other ones, Cura, Slicer, and a few others that are all free, they're all open source, but they do have limitations. There are people who are working on them in their free time. So when it comes to some of the additional features like positioning of supports and things like that we'll talk about in a moment, they don't necessarily have all of those features. And the other benefit of Simplify 3D is it has lots of profiles for your printer in there. So you could actually just buy a printer, select your printer from the list and hit print, and you're going to get probably the best settings rather than trying to work them all out or swap your settings with friends to try and find the best ones. So when you slice a model, one of the biggest things that you'll find is you can't just print anything. You can't print something in free space. You can't print something that has a ridiculous overhang. What do I mean by an overhang? So we have something like this, which I've printed recently, which I'll pass around because I haven't pulled it to pieces yet. But what you can see here is if I was to try and print something like that, I've got things like this which are overhanging. You see that? So the downside of that is, what am I going to print my liquid plastic onto? Nothing. So I'm going to hit print, and it's going to come out the nozzle and just fall to the ground. So you have to be very much aware when you're either one, designing your model, or two, deciding how you're going to slice and print it, about the best way of actually printing it. So, sometimes you can do that, but the other issue you've got is strength of the part. So if you want it to be strong in a certain direction, it may be that you need to print it in a certain orientation to make it strong. So I'm going to pass this one around. This was actually printed like that. And what you can see here is none of this is in my model. This is all something called supports, which we're going to break off in a minute, but I wanted to pass it around just so you could have a look at it, see what it actually does. But what the slicer does is basically print these supports so that you can just snap them off very easily. And then you've got something to actually print onto. So please don't snap it off while you're looking, because other people will want to see it. But once it's all gone round, we'll... Yeah, a bit like that. And then there's something else called rafts, which is you essentially, you know what a raft is, but you essentially print onto a little platform that you're going to throw away. It's not part of your not part of your model. So we'll actually do a slice a little bit later on. So if you're going to do a print, we've done our CAD design, we've done our slice. What do I need to do for my printer? Well, the first thing to do is to clean the bed. If you are using, if you're using a glue stick, it might be that you want to wipe it off and change the glue. For me, one of the upgrades that I've done on my printer is I didn't want to mess around with glue stick or various things. So what I've done is I came across a material that a few other people were using, in fact a lot of people are using now, called PEI. Don't ask me what the PEI stands for. I can't remember the scientific makeup of it. But essentially it's just a plastic plate which I have stuck using 3M tape to the aluminium bed. And it's a plastic which has got a property to it that when it starts to warm up, it's got almost like pores, and the pores open up. When you print onto it, it kind of sucks all the plastic in and holds it nice and tight. And then when it cools down, all of the pores contract again, and the part just pops off. So it means I don't mess around with hairspray or glue stick or any of those kind of things. The other problem with hairspray, for anyone who's used it or is considering using it, please don't, because there are better ways now, is you'll find that people who don't know what they're doing will start spraying the hairspray onto the bed, and it's all sticky and horrible. It'll go all over the bits you don't want it to go on, and it'll mess it up. So if you can get a sheet of PEI and put it on, that's particularly good. I suggest you either do that or get a glass plate and put basically clip that to your aluminium plate, and then you can glue on top of that. And the benefit of that is you can take the glass plate off and take it away and maybe put another one on, and away you go. In fact, also, if the thing doesn't really want to come off of the glass plate, you can drop it in the freezer and then it will pop off. So there's lots of little tricks, and this technology is just moving on at a rapid rate, and people are finding all kinds of things. In fact, there's another company we'll come to a little bit later on, and what they've now got is a removable bed that's held on with magnets, and you put it on, and it's actually spring steel with magnets in it, holding it down to the main element, that's then powder coated with PEI. So it's about as hard as you can get, but you can lift it off and bend it. And then if the part really didn't want to pop off, you just bend it, the part then pops off and it just springs back and you can drop it back on again. I mean, people are moving this stuff on all of the time. So if you've got a PEI plate, and I suggest you do, it's extremely cheap. Again, buy it in China. I bought my first one that I ruined, and I'll come to that a bit later as well, from Amazon, and it cost me quite a bit more. But I think I paid a third of the price and got 3 for the price of a third of the money that I paid from Amazon, buying from China. The important thing about a PEI plate, or any of these plates really, is they want to be clean. Greasy fingerprints are not going to help your part stick to the plate, so you need to make these as clean as possible. So what I typically use is something else I bought from China. Here's just an example of an empty one. This is just a very small sprayer bottle, which I then filled up with isopropyl, and I just have it next to the printer, spray it on, paper towel, clean it all off, perfect. Next thing you need to do is make sure you level the bed. So what does that mean? Well, if you, let's go back a little bit so you can see a picture of the printer. One of the things you'll notice about this is we've got some wing nuts on here. We've got a bolt holding the aluminium plates to the bed and then a spring between it. So if I was to push on this bed in any of the corners, it will move. It will physically move down. So what we need to do is we need to get that nozzle completely level in all 4 corners. So just because the printer is being built level does not mean that this will be level. So for this cheap printer, we have to self-level. And all we do to level it down is basically manually control or tell this unit to go home, which essentially brings the nozzle down to about here. We disable all the stepper motors using the menu, and then we just manually slide this over nice and slowly to the corner of this bed. And then we get a piece of paper, just a piece of A4 paper or something like that, and slide it under the nozzle. And if we get just a little bit of friction on the end of the nozzle, that's perfect. If it can slide really easily, then we need to close the gap. And to close the gap, the idea is you're supposed to move these. These are useless.
They're on each corner.
They're on each corner, yeah, all four corners. These are completely useless, so I wouldn't even attempt to try moving this. It's just too stiff. I even tried 3D printing some bigger ones that I could get hold of, I could grab hold of, but they're so stiff it's just not worth it. So what I did is I just drilled through my little PEI plate just so I could get to the screw head that's on this side. And all I do is I just put a Phillips head screwdriver in there and maybe turn it a fraction of a turn, because it generally doesn't need very much. And then I just manually move the head over to this corner, and I repeat, and you just work your way around. And it might be you need to go around a few times if it's out. But that's it, that's your bed leveled. If you pay more money, you can, or you want to add this feature onto your printer, which I've got all the parts, I just haven't got around to it yet, is you can create something called auto bed leveling, which basically means you no longer have to do this stupid malarkey anymore. You set it up, you get it roughly right. In fact, what some people do is they take the springs out and they just bolt it completely down and it doesn't move. And then what happens is there are some sensors on the side here, and there are various technologies for it. Some of them are capacitive sensors, some of them are like little needles that come down and physically probe the bed. And what this does is it basically takes lots of measurements across the bed, and it creates an internal table to work out exactly how far out this bed would be. And then all it does is when it runs this G-code is it slightly tweaks the G-code on the fly to maybe make this particular stepper motor moves one more click than this one, or whatever it happens to be, to actually keep the bed completely level. So it's, as I said, you get what you pay for. So the more expensive printers will have some of these auto calibration features built in them now, but they are relatively cheap, so you can add them should you want to. You then rehome your printer, which again is just a menu option, and then you prepare to print, which is just preheating the bed and also the heating element to the required temperature for the material. It's plugged into a 13 amp socket. The whole thing is being driven from a power supply like this. It's this is one that I didn't install. This is what it came with, but these are the cheapest and nastiest power supplies coming out of China at the moment. They are borderline acceptable, I would say. There is no active cooling on this at all, and they are just about on the limits of the power capacity. So if you're lucky, all will be well. So what I did on mine was bought a better brand with active cooling, bigger, no issues.
Oh yeah, some of the questions and answers that I've seen on those, it's from one of the sellers, it's something like works perfectly well on UK mains. It comes with a UK plug, but don't plug it into 240 volts.
Oh right.
Which,
Well, okay, you shouldn't have an issue because they've got just a switch. All of them have got switches on the side. So
110, 220.
yeah, 110, 220. So this one's absolutely fine. There are lots of people on YouTube who are stressing an awful lot around the safety of things like this. They're stressing over all kinds of things. But actually what's happened, as far as I can tell, is one person stressed about it, And then because it's such an incestuous thing on YouTube, everybody watches each other's channels and then does their own reviews and comments. They all repeat what the last person said. So in the end, you've got this tall tale about everybody's backing up everybody else. So take everything with a pinch of salt. If it sounds realistic, it's all right. If it sounds like someone's repeating some junk, just think about it a little bit. So you've added MOSFETs to yours, or a MOSFET?
I've ordered a couple.
You've ordered a couple. So that's also one of the improvements I did, just because I see no reason why it's not a good idea. And it's a few quid to add it. We'll talk about that a little bit later on. But that's one of the safety things. Because these boards are made to a price, China is creating these things as cheaply as possible, using the cheapest possible components and putting things right on the edge of their capabilities. So what's happening is you're heating up a bed and an extruder and a hot end and a few other bits and pieces, and sometimes these PCBs just are not able to cope with the amount of power essentially that you need to drive these things.
Single voltage, or is it more?
It is all 12 volts, although there are a number of people running at higher voltages now, but mine is all running at 12 volts. So yeah, essentially some of the changes are an external MOSFET on there, which means all we're using the board for now is just to trigger when we want the heated bed to run, and then using the MOSFET as an external switch and taking all of that current handling away from the board and off to a separate PCB, separate components, separate passive cooling, all that kind of stuff.
Are these things easy to obtain if you go this way?
Yep, really easy. eBay or some of the websites I'm going to talk about later, and they're dirt cheap. So if they're dirt cheap, there's no point in not doing some of them. So some of these things we've spoken about already, about how do you keep your parts stuck to the bed. So there's one thing that I didn't talk about there, which is ABS slurry. Now that allowed me to wreck my first PEI plate. I printed a box out of ABS. Here it is, it's in the right state. Out of ABS, this particular one. And I printed something to start with, and what actually happens if you're not careful, here's one similar box printed out of PLA, is if the part starts to lift off the bed, can you see that's not square? So what's actually happened is in this corner here, it's lifted up, and now the whole thing is deformed. So it's, in fact, it's even worse on that end if you look at it like that. So the key thing is you must have it stuck to the bed. So I thought to myself, well, let's try a different material and see what happens. So numbers of people were talking about this thing called ABS slurry. And basically you make it yourself using all of the parts that you've wrecked previously out of ABS, and you get some acetone in a jam jar, and you basically just feed the acetone with rubbish like this, and it turns into a very nasty, sticky mess, which you then essentially paint onto your bed, and then when you print on it, it basically remelts the ABS and effectively glues it to the bed. What I didn't realise is, or think about, is the chemical reactions that would happen between this PEI and ABS, and it stuck so well I literally managed to destroy this piece, and then it took me a good, I don't know, 2 or 3 hours to remove the PEI off of the plates because it's literally glued to the aluminium plate. So not only did I wreck my PEI plate, but I spent several hours for nothing. So I'll pass this round just so you can kind of see what it's like when you start to wreck things and what it's like inside. But
when you make experimental errors.
yes, exactly. So a lot of this stuff here that I'm going to pass around is will go in the bin when we finish. But I've just been collecting it for when I do a talk like this. I can just show you all the. It's black. You don't want to be You don't want to be recycling black ABS.
No.
So, in terms of tools, well, just for printing itself, blades and scrapers is probably good enough. Probably all you're going to need. I very rarely need a scraper to get a part off unless it's a particularly big part. But blades, and what I mean by blades, I don't think I brought one for fear of being told off by a certain gentleman in the front row. But a blade is essentially just a disposable razor. You know, not razor. It's like a Stanley blade. No, you know the retractable Stanley blades, those kind of things. Why? Because they're extremely thin, they're extremely sharp, they're extremely cheap, and you can get them under parts, small parts, very easily. So, again, I bought 10 for £1 or something somewhere, and they're absolutely brilliant. Sorry?
You usually find them in pound shops.
Maybe. Again, China is my friend on all this stuff. And they're also good for tidying parts up that misprint or something like that. So,
Probably a £4 million tanker previous life before it was scrapped to China.
so yeah, scrapers I've got all kinds of different sizes. I bought loads of them just thinking they would all be useful for different parts, but I rarely use them. Just a big painter's scraper is probably the most popular tool. It needs to be sharp because you need to get under the part. Therefore, don't do it this way, always do it that way. So this slide I put in as a joke a few weeks ago because it's a conversation I've been having with our friend LLZ, and we'd had that speeds and feeds conversation many times over the year. Do we have any engineers who know what that means in here? No, okay. So it's a very common statement when you're machining something around how fast the tool happens to be or how fast you're feeding the particular material into the tool. Well, exactly the same is true when it comes to 3D printing. The speed that you're moving and the hot end around that, the speed that you are feeding the material into, and the temperature that you are printing the material at, all has an effect on the overall quality of the print that you get. So if you try and print too fast or feed the filament too fast into the hot end, you will then hear skipping, and I don't think I have an example here of a particular part, but you'll find it doesn't print correctly and it's failed. So you will end up getting a feel for, or you can print some test prints, getting a feel for how fast your printer can actually print at. Again, I'm not typically in a hurry, so I just keep it slow and steady, and you get there in the end. Temperatures, what will happen is you'll get a spool of filament and it will say something like print this at somewhere between 200 and 230. Well, your printer's probably not, your hot end isn't calibrated really, so it might tell you you're printing at 205 degrees, but is that 205 degrees? Probably not. You can tweak some of these things, but ultimately the best thing to do is just run a few tests with your filament, work out what prints well, write it on the reel and stick with that. Now I'm finding I've got tons and tons of filament, and I can't remember the exact temperature. We'll look it up in a second. But actually, all my filaments are printing pretty well at that temperature, as long as I don't move the head too quickly. So in terms of maintenance, if you were to buy one of these things, well, again, leveling the bed, leveling the Z-axis, which is what we spoke about before, or keeping it level, shall we say, and then keeping things lubricated. Don't start using WD-40 or things like that. I use some 3-in-1 oil, and I also use one of these from WD-40, which is not the WD-40 water remover that you're all used to, but this is a PTFE-based lubricant, which is nice and clean. It's got a long nozzle on it, which means you can reach the parts that you can't normally reach with if you were to take the nozzle off. Another little tip for spools, while we're talking about care. So a spool is something typically about this kind of size. It contains very thin filament, as you saw, and generally you're buying them in weights of about 1 kilo, which means you've probably got several hundred meters of filament on there. Now you imagine something made of plastic, rolled up, and then let go. It will unwind, and you will then have a nightmare to try and sort that back out, because what you want when you're printing is to always feed your filament cleanly and neatly into the extruder. You don't want it to get caught on anything. So if you ever do get a spool unwind, you need to unwind all of that mess and then rewind it back on neatly. So the trick to ensuring that it doesn't unwind is basically don't let go of the end. When you take it out of the hot end, don't just let go of it. What you'll notice in all of them is on the filament rolls, you'll find at the very edges 2 little holes drilled in it. And you get your filament and you just weave it through the holes. And that grips hold of it, and then you put it in your plastic bag with your little silica gel pack, and you put it away.
Why the silica gel?
Because you don't really want moisture getting to these things. So if you can...
It applies to all of them, not just nylon.
It ultimately applies to them all. Nylon is the worst. If you don't want it damaged in any way. Now, some of them, if you do get moisture into it, there are ways of removing the moisture. You can put it in the oven as long as the temperature's not too hot, or you can put it in a food rehydrator, is that what you would call it? No? Dehydrator, food dehydrator, that's it, dehydrator, and pull the moisture out. That's probably the best solution, but most people won't have one of those. So just looking after your filament to start with is easier than repairing the damage that you may well do. So all of my filaments, and I have a lot of them now, are all either still in their heat shrinked vacuum pack where I haven't used them yet, or they're in a Ziploc bag with a desiccant gel pack thing in them. Okay, so we've done that one already, so that's good. Okay, so where can you buy some of these things from? Well, these are the China outfits. We'll just quickly have a look at some of those websites just so you can see how they vary in price. So I'm not expecting, they're just for me, these ones. I'm not expecting you to take these things down other than maybe just remember some of the names. But one of the things that you asked for was, oh look, even Aldi you can buy 3D printers from. So today, or from the 19th, when was it? So we're 23rd today. Today I went to that website to just see what was still there, and you can no longer buy them because they've all sold out. But yeah, it's getting that mainstream that you can buy them in Aldi.
Oh yeah, there's the actual plastic.
It's web only, yeah.
Was that worth its money?
I wouldn't pay 300 quid for that, no. The looks, I can't see quite how big that is, but it looks smaller than my machine, and I wouldn't expect any better quality from anything like that. So my guess is it's you're paying for the fact that it's pre-built. I would expect that to be pre-built.
Yes.
These are metal gantries by the looks of that. That will make it a little bit stronger than the acrylic that I've got, but you can buy other printers with metal gantries.
Filaments on the top there, isn't it?
Yeah, that's so. On this one, it's got a filament holder on the top of this one. I've just got mine stuck on a shelf up here and just sort of runs down. But yeah, you don't have to have it on the top. You can run it just put it on the side and it will feed in.
Vertical or horizontal?
Doesn't really matter. It'll get pulled in as long as it's all good. So just give you an idea the number of 3D printers available. We'll just pick GearBest in this case. So I've clicked on that. Is that actually going to open anything? Let's see. No, it didn't. Wonderful. Control click. So the thing with this market now is every man and his dog is basically producing a 3D printer. And at the moment it seems to be a race to the bottom in terms of price rather than features. So the higher end printers are the one with the new features and all the whizzy things are coming out. If you buy from China, you're probably just buying the cheapest that you can get. But you can see the price of some of these components. They are dirt cheap. The CR10 is quite a popular printer. Not particularly a great printer, but it's quite popular because it's half assembled for you already. So when it comes delivered to you, this is all pre-built, all the electronics are all done, and basically this gantry is done and it's literally just in the box like that, and you just lift it off and put two bolts either side and you've got a working 3D printer. So there's a kind of a balance between how much assembly is required and the cost. But you can see even that heating block that I showed you on mine, if it fails for whatever reason or you lose it or something, you can just buy a replacement and they're dirt cheap. Most of these printers here, here's my one, 130 quid. Most of these printers are what they would call an i3 clone. And that's, in fact, that's actually pretty naughty that this guy has called it a Prusa i3. So there is a guy in, where is he, Austria or somewhere, no, it's not Austria, but somewhere like that, called Joseph Prusa, and he is basically putting out designs for 3D printers and open sourcing them. His printers are reliable, loads of features and functions. He's using the best materials available. He's producing them as a kit or pre-built, and they cost considerably more than these cheap printers that they're basically just ripping off from him. They are about 800 quid, I think, so they're not bank breaking, but you're getting all of the bells and whistles that you're not getting with these. So in that case you're getting, I'll show you a picture actually in a minute, but you're getting things like that springy board, you're getting auto bed leveling, you're getting brand new electronic boards that have been designed precisely for this this particular task. But the point of this whole exercise is just to show you, you can pay 600 quid for a cheap clone, or you can buy 132 quid for a cheap clone, or you could give somebody who's actually investing in the community some real money and get a supported printer. You do not get any support with this printer at all. You're on your own apart from other people who've owned that printer who are doing things. In fact, you don't even get support from the people who sell it to you. When I got mine, there were several parts missing and several parts broken. I asked them to send me the broken parts or replace the broken parts. They said, well, how about we just give you 25% back? And I said, well, how about you give me the missing parts or the broken parts? Because, you know, I may have a non-working printer for that. And they said, well, we'll give you 25% back then. Well, by that point, I'd looked at what was broken and realised that if I just glued it together with a bit of super glue, I would be in business. And that's what I did. So I got 25% back off of that, and it cost me even less money. So, so it wasn't too bad. But the point is, there are billions of these. They all look the same. They all work the same. Some of them are better quality than others. So typically, all of these cheap ones would either be USB, or what I prefer is just an SD card. And then you just can completely leave it away from a computer. You don't have to have a computer at all for that kind of thing. However, I'll talk about something else in a minute, so we'll come back to that. But typically, USB and SD card. So you can see here, anything's replaceable if you're willing to put the effort in. You can buy filament from here, you can buy filament from the UK, you can buy filament from anywhere on the planet. They are varying qualities. In the past, the cheaper filaments used to be pretty poor. Nowadays, there doesn't seem to be a particularly poor filament. So I bought recently 20 spools of filament, I think, from all different colours, clear ones, natural colour, blacks, red, orange, pinks, you know, you name it. I found them for £5 per roll, and I thought, that's worth a punt. Yeah, that's worth a punt. And that was coming from Amazon in the UK. That's worth a punt, because if it's bad, I can send it back to Amazon UK, and distance selling means they have to accept it back. The downside of £5 a roll was something, I can't remember exactly what the figure was, we can check it if you're interested, but it was something like £8 a roll postage. So I sent them a message and said, I'm going to buy 20 rolls. Do you really think 8 times 20 is a reasonable shipping price? And they said, okay, well, we will give you 18 times £8 back. How does that sound? And I said, that sounds great, send them immediately. So that's what I did, and I got 20 kilos of plastic delivered the following day.
That's Sam,
I got 20 kilos delivered the following day, and and I get a new colour out occasionally. And then she says, where did you get that yellow one from? But yeah, so I started with just a small roll of white that came with the printer, and black and red, and now I've got yellow.
Did you say to your beloved, that's been there for years, how have you noticed?
You want to see the security of his gallery.
So anyway, it's I've got, I think, almost every colour you could ever want to print in. I haven't got any of these infused ones or hybrids or anything like that.
You're not printing anything for Sam, that's where you're going wrong.
No, I'm not printing anything for Sam. But it's, you know, at £5 a roll, you can't get, it's worth doing it, especially if I'm only going to pay the postage once, essentially. So it worked out far better. Anyway, let's jump off this, because none of this is interesting. We should have something. Let's actually get into the nuts and bolts of this, because we're already 9 o'clock. Okay, so we've done that one. So essentially you slice your model, it turns into something called G-code, and G-code kind of looks like this. It's just numbers, essentially, just commands, and that's kind of what they look like. You don't ever need to even look at them unless you want to do something very custom with your printer. But if you're interested, that's what they look like.
I take it all the text is annotation.
When you're
You don't normally get that.
slices out,
Yes.
presumably the fact that you're using a different thickness of filament will affect the...
Yep, so you tell the slicer everything about your printer, the materials, all that kind of stuff, and it works out all of the magic. So this isn't normally annotated, this is normally just a very tiny file. This is just to kind of illustrate what actually happens. So this printer that I said is very popular from Joseph Prusa. This is his latest design. You can see it looks fairly similar to mine. It's just considerably better. All of this is made of steel, so it's rock solid, but it's the same kind of idea about a power supply at the back here. All of these orange things here are actually all 3D printed.
That looks like a Lego brick.
You've got the control at the front here, but the latest element is these things at the top here. So what these are is 4 additional stepper motors, and he's created another board which sits over here, and we only have one hot end like this, but actually we've got 4 filaments running into that. So rather than having the typical arrangement of having 4 hot ends, this guy has managed to get this working with 4 independent filaments all going through one hot end. The reason that it's easier to do it with one hot end rather than multiple hot ends is I explained the process about ensuring the bed is level and all of the calibration you need to do. Well, imagine if you needed to do that calibration 4 times, but on top of that, you would need to know exactly, you'd need to know exactly how far away all of these were from each other, so that the slicer could tell how much it needed to move each of these elements to get exactly to the right hot end. So this guy has designed this. It's literally a few months old, 2 months old or something, and he's sold thousands and thousands of these. The other benefit of his kits is everything's upgradable. So this is the i3 Mark 2.5. I think we're at the i3 Mark 3 now. But if you bought the first version, all of the parts are open source enough, or you can buy them directly from him just to take all the old bits off and put all the new bits on. So you can keep moving your model forward to the latest and greatest with no... Yeah, so he is moving this industry forward. And the way it works, this particular one, you see this block here on the bed, looks like a Lego brick. So this actually will get taken off and thrown in the bin. This is a scrap block, essentially. So what's happening is, imagine a red filament is coming down here to print this red. So you'll print some red, and then what will happen is the extruder will suck that red back in here, run off to this block, and work out what the next colour it needs to print is, and then start squirting that down here, and basically clean the nozzle over here, and then it will come back to the part and print the right part. So what you can do is you can actually start mixing colours. And for anyone who's not seen it, I'm going to pass this around. This is some yellow filament that I've mixed into black just when yes, just in your hand. So that's come out the hot end, and that's just when I changed the filament from black to yellow or yellow to black, whichever way round it was. But you can see how they've used that technique to actually be able to mix colours. It's very clever. And considering it's only slightly more than these cheap Chinese printers, really, if I was buying one again, I would buy one of these, not a cheap Chinese one.
James, can you explain how you would have built that up then? Would you started with the white first? It looks like a bangle.
Exactly. So what it will do is it will start with the white, and it will be printing in a circle to start with, and then what will happen is it will come up to the point when it needs its first yellow one, for example, and then what it will do is it will move off to this scrap block, and then it will just start getting rid of all the white until it's yellow, and it knows how much of filament it needs to squirt through to be able to clean itself, and then it will come back here and it will do that little bit of yellow, and then it would probably come back here and put some more white in and do a bit more white, then the red, then the green. So it will take forever, but all computer programmed, but you've got a print in one part. It's not, you've not had to print just the white thing and then knock all the supports out of it and then print a load of green things and maybe glue them in. You have one solid plastic piece of coloured material. Now, in terms of strength-wise, that's particularly handy. So pretty much. So if we get some time, I'll show you a video of how that works, but I've already rambled quite a bit. So in terms of how you would finish your print, it depends on the materials that you are printing in. So we had, where did that red? Thank you. So we printed this one here with some supports. So if you print and you require the supports to come out, the first thing to do is to know what your model is like and what's a support and what's not, and just start pulling them out.
I take it that's part for your printing?
That's a part for the printer, yeah. So what this actually is, this is a complete replacement for the gantry on the top there that will take one of these hot ends, and ultimately will also take a auto bed leveling sensor, which will sit on the top. So actually this isn't just, there's a whole series of parts here, from fan guards to more ducts to all the relevant bits and pieces. But no, I just downloaded these off somebody else who'd done the work, and that was that. So, you know, you can see how easy it's all coming off, and then it looks great, doesn't it? So.
And you can melt down the plastic
No, you can't. No, you can't reuse the plastic. It's gone. But the important thing is that you'll see here is it's actually used.
How simple.
It's used the minimum amount of plastic that it could get away with to do that. So it's particularly good.
I can see how many more answers.
So if you have printed with supports, you just pull them off. Now, here's the cool thing about that previous printer that we showed you. You don't have to print colours. You can print in other materials. So you could put a PVA-based filament in there, and you could print supports of a different filament, so PVA. And then rather than pulling all this stuff off, if it's very, very complicated, I could just drop that in water and they will all dissolve away. So it's really clever. You don't just have to mix colours. In terms of polishing, you can see that afterwards some of these things, they do look like, if I pass some of these around, you know, they are layered. You can see whatever happens on an FDM printer, you're going to see layer lines regardless of how big the nozzle happens to be. But if you're printing out of something like ABS, you can actually polish them up. And what you can do is you can use our friend acetone again, and you can use acetone fumes, and you can basically put them in a box with some acetone and a piece of tissue, and it will effectively melt a very small amount of the outside of the ABS and polish it all up. If you're using anything else, well, the only options you've got are sandpaper, priming and painting. It's very easy to sand. What I will say is if you do paint them, if it looked bad before you started, it will look worse when you paint it. So preparation is very important if you're going to do these things. But you know, there are some amazing things that people are doing with 3D printed things and painting. You're seeing people creating movie quality props with 3D prints. But you need to put the time in to maybe fill in the gaps with you know, body filler and all that kind of stuff. But it gives you a good head start. So this is kind of what it would look like if it's printing. This is my PEI plate, and this is printing one of these parts here. I might have been printing this part. I think if I pass that round, you'll see how intricate that part is. There's no way you could machine that. So yeah, what you can choose to do is get an outline of the part, and I always switch that on for the simple reason is I know definitely it's going to print okay on my bed. If it starts to try and print too close to the edge or something like that, I know it's not going to fit. Whether that's the reason for that, I'm not sure, but even so, it's a good way also to make sure initially that you have got your calibration right, because if this stuff doesn't stick, the rest of it's not going to stick. So it gives you a good indicator within the first 10 seconds or so that everything is good. In fact, the other thing it normally does is prints a big red line from the homing position all the way over to about here. So normally what happens is I get my blade, and as soon as I see that stuck, I just slide it under while it's still moving the plate around and just get rid of it. Some of the other changes I've done to my one is I've put some LEDs in there, which are basically just a strip of LEDs like this, but all the way around. The good thing is they provide light, so you can see how the printer is going. But the other thing is these are coloured LEDs. And what you can do is you can squirt G-code, special G-code commands that colour the LEDs. So imagine when the unit is heating up, they're red. When it's printing, it's white. When it's cooled down to a safe temperature, it goes green, and you know, whatever. It's just a bit of fun.
Is that you modifying it in the version on the back?
No, that's a hot air reworkstation at the back there. So yeah, some of the things you can see, there's that bolt, for example, that I was describing. You push that down and that releases the wheel that allows you to pull the filament out if you're going to change it. So if you were going to change the filament, you heat up the hot end until it's nice and hot, effectively ready to print. And what I normally do is push this bolt down, get hold of the filament because there's nothing holding it now, push it down, and I should see it squirting out here. And as soon as I can see it squirting out, yank it out really quickly, and hopefully you'll get a nice clean tip out the other end.
So that's the red filament going.
And then don't let go. Yeah, I have let go twice.
The bolt doesn't get hot for you to be
No, because that's the whole idea of the heat break, is the heat break is being actively cooled, so you are well.
That meter's on the back wall, is it? It's not part of the actual...
No, that's just some tools I've got on a shelf. So this is the control interface. It's all done with one knob that you just rotate round, and you just get some menus and you can push the button.
You're looking at them through things.
Yeah, you're looking directly through it. So you can see that's just sat on my workbench. It doesn't take up much space and it just prints away. I did to start with. This is another important thing here. You don't get this with any 3D printer I don't think of, but it's certainly worth doing. So my particular one has got the board at the very back in the most inconvenient place with a plate in front of it to really get to the SD card. So it's all very well if you were printing with USB, you've just got a USB cable out. But if you're doing something that could be a 16-hour print, you don't want to leave your computer on all the time, you just want to let this thing run. So what I was doing to start with is reaching over the printer and trying to wiggle this SD card, which is half the size of a stamp, into this little thing that you can't really get access to. So I bought one of these things here, which is basically just an extension cable for an SD card. So just double-sided taped it to the top, so now it's really easy, push it in and out it comes, and that ribbon runs all the way back and then plugs into the board at the back here.
So a lot of stress on the board, is it?
Absolutely. So it's really convenient, and again, cheap from eBay. I think that one, £2, maybe even less than that, for loads of convenience. So that's what the power supply looks like that some people are freaking out about in terms of health and safety. It's tucked at the back. Unless you really want to reach round and lift up the hatch and stick your fingers in there,
No.
you're not going to electrocute yourself.
Print yourself a cover for it.
Well, and a lot of people are, but no one's allowed anywhere near my printer. So the last thing I'm going to do is go fiddling around with it in the back with it.
It's like that, curiously.
They like the idea of it, but they wouldn't touch it. So this is the upgraded power supply, and you can see everything's anchored down and crimped on, so it's all about as safe as I can get without printing a cover for it. But again, there's loads of kits that you can, loads of STL files you can download for creating covers. So there was my damage. This was the biggest piece of damage, was this top piece of acrylic, completely snapped through, and I just got some super glue and super glued it back together, and it's been absolutely fine. So I got a nice discount for that. There was another piece that was snapped, but it was so small and I don't think I could find the other piece, but it was in a non-critical area, so I just left it, and that's not been a problem. So there's another thing called Octoprint. Now you asked about how does it interface with your computer, and I said, well, USB or SD card. Octoprint is some software which runs on a Raspberry Pi. It can run on a Raspberry Pi Zero, so the cheap £5 boards. It runs a version of Linux on there, and what people use that for is remotely monitoring the state of the print when they're not there. So there's some examples of the screens, and what they actually do is they plug a webcam into it, and then they can use a computer in another room or their phone if they're at work or whatever it happens to be, and they have full control of the printer and can see what's going on with a video stream. You can see all the temperatures and where they get to on here. It's basically like being there, and it's all available for free. So that's quite good. Print examples. I'll just show you a fun print.
Actually change to the usual dragon.
Oh yeah, that's one thing I said to myself. If I'm going to buy a printer, I'm not going to print any stupid stuff. It's only going to be stuff that I physically want else I'll end up being like everybody else on YouTube who just print stupid stuff just for something to do. However, just because it's useful doesn't mean it can't be silly. So I was working on a project the other day. I needed to ensure that I didn't lose all of the screws. I didn't have a box around that had a lid on it, so I printed one of these things. And it's basically a little iris, thing, so you can pass that around. And all I did is just put all of the screws in there. You printed it in about 5 or 6 parts. I mean, there's an example of one that I broke putting it together. I think, was this one I broke, or was this one it broke? Yeah. But yeah, so you can print some funny stuff. And then my kid said, "That's brilliant, can you print one for me?" Well, what do you want it for? I don't know, but I like it. So some of the other things I printed, other than boxes and things like that, was the most boring thing I could possibly think of, was a box perfectly sized to go in my pellet case to hold my cables. And when I say perfectly sized, I went in there with rulers and measurements, and that is perfectly sized to fit in there so it doesn't move about, and the walls are nice and strong. Yes, I could have got a couple of bits of plastic and taped them together. Probably would have cost me the same price. Yes, I could have laser cut them. It would have probably cost the same price. I went in here, caddied it up, took about 5 minutes, sat it printing, forgot about it, and I now have a nice solid box. That was a long time, because actually I can't print something that big. That's about 40 centimeters, I think. It's quite big. So it's too big for my 220 plate. So what I actually did is this isn't the one, because this is very thin walled, just to see whether I could get away with thin walled. And actually you can't, because it all cracks and it's horrible. So this is the thinnest layer that you can print. And actually that's no good if you're printing something of that kind of size. So what I did is printed 2 of these, a lot solider. You can't see the join in there, but I effectively set them in together and then just put some tape, Gorilla tape or whatever it was, around the outside, just to kind of make sure that the levels didn't change, and it fits in there perfect. The other thing I printed was the bell. Some of you will recognise this. This is something that got people laughing at the HF convention, but this is essentially just a plain box that I caddied up, but then I put all of the holes in and printed special holders for what are these called, power pole connectors. So they look like, just tiny little plastic things like this, but they are strong enough to be able to go in here and hold these in there. And then I've just released these, so if anyone wants to print them themselves, they can get hold of them and download them from the website. And that's.
So you get to bring you a cup of tea in the shack.
No, this has some. You haven't seen this. Oh, I'll show you. I'll show you a video. We're running out of time, but so this is a fun little project where holes were important and they needed to be in the right place and the right size and all that kind of stuff. Yes, I could have probably got a project box and measured it all out and all that kind of stuff. Number one, it's not repeatable. There are now tons of people actually making these all over the world. And number two, it would have probably taken as long to have bought the box. No.
Those bells this weekend will be ringing all over the world.
Yeah, yeah. There's a contest group in New Zealand who've made one of these. And then also there's another little fun project box that controls the K3, and I'll definitely show you that in a minute. But you can see all the parts in there. Some of them are 3D printed, some of them are holding PCBs and various other bits of stuff. But it's a VFO knob for a radio, and I even 3D printed and designed the knob. So there's a bad version of the knob before it got changed into the final one. The hole's a bit small and things, but you can have a look at that or see the real one.
This solid?
No, it's not solid. Yeah, it is. Jonathan, we may have to actually do another practical one because we're running out of time. I just thought I'd show you another bit of fun. This is called a hang printer. This is probably about the cheapest printer that you can build. You can't buy it as far as I know, and I'm going to have a go at building one. And it's basically a few bits bolted to some 3D printed parts and a load of fishing wire or kite strings. What it allows you to do is print,
Oh my goodness,
okay,
look at that.
which now allows you to print things like that,
Just don't have a cat in the house.
which is totally fun.
Yeah.
I would show you a video of it, we haven't really got time, so let's actually just quickly belt in and start showing you some of the practical things before we do run out of time. Rather than showing you CADing from scratch, I'll probably show you some of the models that I've already done. So this is Fusion 360. This is the software I recommend. Yes, it's very expensive if you're using it professionally, but if you're a hobbyist, it's totally free. So if the professionals are using it, to me, it sounds like the best software to be using, especially as soon as they're giving it for free. So you can see some of the other projects. There's the one for the K3 insert. Here's something I designed the other day just to get around a problem with the MFJ analyzer switching itself on when I didn't want it to. So I just designed a special guard that I just double-sided taped onto the front of it, and it stops you accidentally pushing the button. You have to physically go in and do that. So let's have a look at the knob, which is that box here. So that's a few different components. Yeah, we don't need any of the recovery files. So that should load that up. So here's the knob. You can see I've actually even designed or modelled up, should we say, the encoder that goes in there. So that wasn't being 3D printed, nor was this PCB, for example. In fact, this PCB was exported out of Eagle, so I didn't need to model that up. But I did model up the encoder. And if we turn it over, you can see I've modelled up the button that was in the side there, the hole for the LED, the knob itself. There's the inside of it, the bracket that holds the thing, and it looks really complicated, but it isn't. It might be if you know nothing. Like when I started, I knew nothing about any of this, and the only way I got to be able to do that, this was my first project, was literally doing it and working out how to do it. So you can see various things on there. So there's the knob, the button, and they're all separate things. So if I wanted to take that knob and use it in another project, it's a separate component, and I could do that. If I wanted to use the button in another project, you can see I've only really done the outside element of it because that's visually all that I needed to do. But they're all separate things, and you can turn them on and off. You could see if I turn the knob off, for example, that one, you actually see the screw holes underneath and where the encoder pops through. So the important thing about with that is you need to know what you're modelling. So some of the tools that we didn't go through that are quite useful is some long nose pliers for pulling these things out. But pretty much, the only other thing that you really need if you're 3D printing is just a set of cheap digital calipers, just for measuring stuff up. And that's all I've done with a lot of this stuff, or use the data sheets. And then you can put all this kind of stuff together. And then ultimately, just to slice it, you would run it through a piece of software like this, where you load a file in. Have we got any STL files that we can load in? I think we have STL, like my Jeeves box, for example. Drag it in. That's how it would print. Obviously, that's not the optimal way of it printing. So historically, I did this whole long-winded process of rotating it round, and then I found there was something in here called place surface on bed, and then you pick it, and then magically it appears on the bed. So that's what it's going to look like when it prints. I've set all my processes up already that talk about temperatures and layer heights and all that kind of stuff, so you don't need to worry about setting that up once you've done it for that particular material. You hit prepare to print, it thinks about it for a bit and then creates essentially a model which you can then check by running through the process. Let's do it that way around. You can see exactly how it would print and is it going to print anything badly.
Is that a manual process? It doesn't sort of warn you or anything?
There are some, oh, do you know, I haven't had anything that's that bad, because what you can do is you can, in here, this is just a hole at this point, but you can turn on something called supports, which will basically print, you know, a support in between here that you can then break off. So I haven't tried to print anything that's impossible, so I don't know, but more than likely, it will tell you if your model's rubbish. It will come up and tell you things and then you can repair your model. But in terms of will it actually turn into some mess like we saw on that, I've not tried that. And then from that point, you just load it into your printer and hit print, and magically it comes out. So that's probably, we've rushed through so much stuff, but essentially that's probably gives you a...
It's a big subject, James.
It is. It's taken a couple of months, I think, to get to this point. So there's still lots to do and lots to learn.
You're going to do a YouTube series.
No, there's plenty of people on YouTube teaching you everything you ever want to know. So if you want to, I find all the fusion stuff, there's someone on YouTube giving you a demonstration about how to do, you know, something like that. So that's how I've learned how to use certain tools in there, or you do something wrong or the long-winded way and then find there's a great feature built into Fusion 360. So you can create a bolt just by creating a cylinder and then say, put a thread on that please, and it says what kind of thread do you want? You say I want, you know, this size thread, and it says do you want a left-hand thread or a right-hand thread? and then just click it and magically you've got you've got.
Right, James, we're going to have to. I think really, rather than doing a talk like this, we're going to have a series of talks like
I think
this.
we ought to, yes.
Yeah, and what comes next, sort of thing. But brilliant, James. So doesn't he make it sound easy when he talks about it? Jonathan will tell us in the end. Thanks very much, James. Brilliant. Thank you.